Let's begin with the next method, that is distance of a nearby star by parallax method. You can see the figure very well. You will see that there are two farthest points whose line of sight are almost straight lines. Clear? Now how to measure the distance of a nearby star by parallax method? Let's see step by step. The very first thing, as shown in figure, I am writing the entire method with the description. As shown in figure, suppose n, can you see n this? Yes, n is the nearby star whose distance d. Can you see this d? Yes, you can see this d. Distance d from the earth is to be found. How far that nearby star is located from the earth, that we need to determine. F is a star. F is a far off star, or you can say star which is very far. You can say which is very far, or you can say far off star whose direction and position is fixed. Not changing, fixed for all position of the earth, for all positions of the earth, because earth is revolving as well as earth is rotating on its axis. So F are the such stars whose position are fixed, which are not at all changing with the rotation of the earth, revolution as well as rotation. Clear? All positions of the earth, you can say, in its orbital motion. When the earth, remember, when the earth is at position A, can you see the position A? When the earth is at position A, the parallax angle between the distant star, between distant star F, distant, why I am saying, because it is located very far away, distant star F and nearby star N. Can you see distant star F and nearby star F? The angle, parallax angle is given. Which angle it is? Theta 1. Between what? Far off star F and nearby star N, at a position when the earth is at position A. At this position A, when the earth is at position A, the angle between the far off star F and nearby star N is how much? Theta 1. Let it be theta 1. After 6 months, clear, the earth is at diametrically opposite means opposite to A. Opposite to F is straight diameter, right? A is the diameter of this orbit. So you can say diametrically opposite means what? It's the other endpoint of the diameter. Means after 6 months, the earth will not be at A, but earth will be at B. You can say that A and B are the 2 points of the orbit, diametrically opposite points, which are 6 months apart. 6 months apart means to complete one division it take 12 months. A year, you can say, right? So at the 6 months, you will see that it will be opposite to the starting point. It's A. After 6 months, it will complete half revolution. Yes or no? So earth is at diametrically opposite position B, you can say. The parallax angle, now the parallax angle when the earth is at position B for the far off star F and nearby star N is found to be how much? Theta 2. Very good. The parallax angle NBF is found to be how much? Theta 2. is measured. Clear? Now can you see these are two alternate angles, this theta 1, this theta 2, alternate angles, two parallel lines cut by a transversal. The angle included are alternate opposite angles, that is theta 1 and this will be theta 1. Similarly these two parallel lines, this is your transversal, so these two are alternate angle. You can find z over here. Can you see z? So theta 2, this is theta 1, theta 1. So total parallax angle subtended by n on the Earth's orbital diameter. This is Earth's orbital diameter. This AB is known as what? Earth's orbital diameter. The total angle subtended at the Earth's orbital diameter by the Earth's orbital diameter to the nearby star is theta 1 plus theta 2. You have to add this to theta, yes or no, in order to get your entire angle. So the total parallax angle subtended by n on the Earth's orbital diameter AB. This n is subtending the angle and the diameter AB, that is how much? Theta is equal to theta 1 plus theta 2. You have to add both the thetas, and we know that as angle theta, that is equal to what? Arc upon radius. Everybody knows, yes or no? So therefore theta is equal to, what is arc? You can say diameter, orbital diameter AB. What is radius? You can say what? This radius is nothing but what? This, that is d. Therefore d is equal to, if I want to find out the d, then d is equal to what? AB by theta. D is equal to AB by theta. Clear or not? You can write the last statement. The parallax method is useful for measuring distances of stars which are less than 100 light years away from the Earth. Away from those who are situated 100 light years away from the Earth, less than 100 light years from the away from the Earth, you will able to measure the distances with help of parallax method. Till this clear? Now how to determine the diameter of the moon or any planet. So let us discuss the method to measure the diameter of moon or any planet. Method to determine diameter of moon or any planet. Fine. You can see the figure very clear. AB, that is the planet whose diameter is d, we need to determine. The planet is situated from the point of observation from the Earth, which is at a distance s, and this diameter subtends an angle at theta to the point of observation on the Earth. Three things: diameter of the planet, that is AB, that is equal to d. The planet that is situated from the Earth, which is at a distance s, this is also clear. The angle subtended by the diameter to the point of observation on the Earth is how much? Theta. With the help of secant you can measure theta, or you can say with the parallax method you can measure the angle theta. Clear? You know the distance s of the planet. By parallax method you can determine d easily. So let AB is equal to d be the diameter of the moon, or you can say, or any planet you wish to measure the diameter, which is to be measured by an observer O on the earth. A telescope is focused. With the help of telescopes you can find this angle theta. A telescope is focused on moon, and angle AOB. This is your observer point determination by AOB subtended by it on the planet, on the point O, you can say, of the earth is found. Now everybody knows the formula. Angle theta, that is equal to what? Arc by radius. So theta is equal to what is arc? That is your diameter, that is your AB. Radius you can consider as OA or OB, whatever you wish to write. Therefore this is your D, this is your S. So in order to determine this diameter, D is equal to what? S into theta. This you can calculate by parallax method. This can be calculated by telescope that has been focused from the point of observation to the diameter. If this both two are known quantity, you can find the third unknown quantity. D is equal to S theta. You can write this as linear diameter. Linear diameter is equal to S is what? Distance into theta is nothing but as what known as angular diameter. Theta is known as angular diameter. You can note that knowing S and theta, D can be determined. D can be determined. Hope till this clear. Now moving to the very next important topic. The very next method that we are going to discuss is how to find the distance of a nearby planet, the distance of the moon, the depth of the seabed using sonar. That is an application in order to find out the depth of the sea using sonar. How we are able to determine these distances using a reflection of the wave, that we are going to study in the next theory. So next theory is method to measure distance using reflection. Method to measure distance using a reflection of waves. Clear? Now see the figure very carefully over here. See, there are various methods you can use in order to determine the distances using reflection of the waves. Either you can use echo method, in which sound wave is projected. Either you can use laser method, in which monochromatic wavelength laser is being projected. In case of radar, you will able to see that radio waves are being sent from the transmitter. In the case of sonar, sound waves or ultrasonic waves are projected, whose frequencies are more than 20,000 Hertz. Principle is same in all the cases, but different as per based on different applications. Different entities are being transmitted from the transmitter, and which is received by the receiver after some time t. As the time delay is being noted, second thing, time is known to you, speed is known to you, you can calculate the distance of the object where it is situated. Here you can see very clearly. Before moving to the topic, let us see how it is being used. Suppose your object is located over here. Clear? What they will do, from the transmitter, there are two components: transmitter, which sends the signal, or you can say which sends the wave. There is one component that is receiver, which means which receive the signal after it is being projected, reflected back from the object, you can say. When this signal from transmitter is sent to the object, it will strike to the object, reflected back which will be received by receiver. During this process of transmission and receiver, some time will be lapsed into it. Clear? If I am throwing a ball on the wall, the ball will try to strike the wall and will return to me again. There will be some time lapse, yes or no? This phenomena will have some time lapse. If I am having time recording instrument which will record the time of this entire process, number one. Second, if I know the speed by which I have projected this probe wave, clear? So I know speed, I know time. So speed is equal to what? Distance upon time. So I can calculate easily distance is equal to what? Speed into time. This is the basic method which we are using to measure the distances using reflection of the waves. There are two components. First is transmitter, which transmits the waves, which sends the signal. One is receiver, which receives the signal that is being reflected from the object. The transmitted signal is known as probe wave. The receiving signal is known as reflected wave. And the time elapsed during this process is t, denoted by t. Clear? Now I will tell you very basic phenomena in various process we are going to see. The very first I talked about, that is echo method. Echo. Here, in the case of echo method, you will able to observe that you will able to sound wave is being projected. Sound wave projected. Yes or no? Second is laser method. Laser method. Second is laser method. Second is laser method. Laser method, what is full form of laser? Light amplification. What is full form of laser? Light amplification. Light amplification. Light amplification by stimulated emission of a radiation. By stimulated emission of radiation. You'll able to see a high monochromatic wave is being projected. Clear? Third is radar method. Third is radar. What is full form of radar? Radio detection and ranging. Radio detection and ranging. Next is sonar. Full form of sonar is sound navigation and ranging. Sound navigation and ranging. Hope this is cleared. Fine. In the case of sonar, they are projecting what? Ultrasonic waves. Ultrasonic waves whose frequencies are greater than 20,000 hertz. Greater than 20,000 hertz. These ultrasonic waves are sent. Now you'll able to notice that we know the formula. Speed, that is equal to distance upon time. Yes or no? Here speed we can say is v. Whatever is projected, either laser is projected, either radar is projected, either ultrasonic waves for the case of sonar is projected. So speed that we already know, that is v. Distance over here, one is s for traveling from transmitter to the object. The same distance it had to travel to the receiver because transmitter and receiver are together. So again s. So s plus s is how much? Distance is how much? 2s. S plus s. Total travel is what? 2s. Yes or no? Speed we know, that is v. Distance is what? S. Again s. So s plus s is how much? 2s. And time lapsed in entire process is how much? T. Clear or not? So I can determine this. 2s, that is equal to, I can multiply this to, that is v into t. I know v, I know t. So I can determine as s is equal to what? I know v, I know t. I can determine as s is equal to what? V cross t divided by 2. This is the simple method in order to determine the distance by echo method, laser method, radar method, sonar method. Principle is one and the same. Now moving next to the example that is given in your NCERT, that is example 2.1, illustration 2.1. you can say you have to calculate the angle, of A. You have provided 1 degree, B 1 minute, you can say minute of arc or arc mean, and C you have to calculate 1 second, you can second of arc or arc second. You have to calculate these values in radians. Now they have told that you have to use this 360 degree. Everybody knows that is 2 pi radian. 1 degree, that is equal to 60 minutes, and 1 minute, that is 60 seconds. Till this clear? Now how we'll use? Very nice question. We know that, I'll write, what we know that 360 degree, that is 2 pi radian. From this I can write pi is equal to 360 by 2, that is 180 degree. More you can write as pi radian. Yes or no? Clear? I can write one thing over here. We know that 180 degree, that is equal to pi radian. Yes or no? So if I want to determine 1 degree, so 1 degree is equal to pi by 180 radian. Instead of pi, what I can put? 3.142 divided by 180 radian. So let's calculate. 3.142 divided by 180. Your answer is 0.01745. If I move 2 points, that is 1.745. I am moving towards left or right? Right. So I have to put what? 10 power minus 2. Unit will be radian. Till this clear? Moving to the next. We have already determined that is 1 degree, that is equal to 1.745 into 10 power minus 2 radian. We have already derived right now. Now 1 degree is how many minutes? 60 minutes. So if I want to determine 1 minute, I have to move this 1 by 60 degree. So 1 minute is equal to 1 by 60 degree. If I want to convert this degree into radian, I have to multiply for 1 degree how many radians? 1.745 into 10 power minus 2 radian. So 1.745 divided by 60. 1.745 divided by 60. I am going to get 0.02908. This is 10 power minus 2 radian as such. I have to move again 2 point, that is 2.908 into 10 power. I have shifted 2 position, so minus 2 again. So 2.908 into 10 power, how much? Minus 4 radian. More precisely I can write as 2 point, this is 8 more than 5. So I have to shift 1 in the previous digit, add 1 to the previous digit, that is 2.91 into 10 power minus 4 radian, that is what? 1 minute. Clear? Moving ahead to the next, that is we have got 1 minute, that is equal to 2.91 into 10 power minus 4 radian. Also 1 minute, how many seconds? 60 seconds. If I want to determine 1 second, so 1 divided by 60 minute. So 1 second, that is equal to 1 divided by 60 minute. Minute to radian is how much? 2.94 into 10 power minus 4 radian. So let's check. 2.91 divided by 60. I am getting 0.0485 into 10 power minus 4 as such. Again I have to shift 2 position towards right. 4.85 into 10 power minus 4, 2 position towards right means minus 2. So answer is 4.85 into 10 power minus 6 unit radian. This is for 1 second. Hope it is clear, the entire numerical to you. Clear? Now let us see the example of assignment 3, question number 5. A rock under water is 1595 meter deep. S is given 1595 meter deep. Find the time in which an ultrasonic signal returns after reflection from the rock given the speed of ultrasonic wave in the water. Speed is given, that is V is given 1450 meter per second. So we have to determine the time. We know the formula, V is equal to what? Distance, that is 2s upon time is what? T. In order to determine time, T is equal to 2s by V. So 2, what is S? 1595 divided by speed is 1450. So we'll get the answer 2 into 1595 divided by 1450. Your answer is 2.2 seconds. Clear?